Problem 2. Given that the sine of theta is 3/5 and that theta is in the first quadrant, find the cosine of 2 theta. So it's a double angle here. So we're going to use one of these formulas. Since they gave us sine, it only makes sense to go ahead and just use that formula. So I'm going to do 1 minus 2 times the sine value squared. What is the sine value? 3/5. And I square it. Well, so that's 1 minus 2 over 1 times 3/5 is what? 9/25. So 1 minus 2 times 9 is 18/25. Well, 1, we need to make that have a common denominator with 25. So 1 is the same as 25/25. 25 divided by 25 is the same as 1. And we're subtracting 18/25. That'll give us a grand total answer of 7/25. The nice thing is most of the time when we're doing the cosine of 2 theta, we're either going to use this formula if they give us the cosine here, or we use this formula if they give us the sine. If they give you the tangent, you're going to have to draw the triangle to get the third side, and then you can use any of the 3 formulas you want. And that's what we're going to have to do here in problem B. It wants the sine of 2 theta. The sine of 2 theta, what's 2 times the sine value times the cosine value? I already have the sine value, but I don't know the cosine value. So I'm going to have to look at the triangle. Here's theta. It says the sine of theta is 3/5. So sine is opposite over hypotenuse. Well, we recognize this. We could do Pythagorean theorem and say a squared plus 3 squared equals 5 squared, but at this point we recognize a 3, 4, 5 right triangle, a Pythagorean triple. So now I have my measurements. So it says do 2, we're just going to do is 2 over 1, times the sine of theta. Sine is opposite over hypotenuse, 3/5, times it says do the cosine value. The cosine is adjacent over hypotenuse, 4/5. When I multiply all that, I get 24 on top. 1 times 5 is 25 in the bottom. And that's what we'll get for the sine of 2 theta.